We will now extend our idea of having fractional factorial designs to the extreme. So we will now analyze many factors at the same time. So let's say that we are screening drugs and we expect that most of them will not have any effect. And we also expect that there are no interactions between compounds. Can we screen many different compounds with as few runs as possible? If very few effects are expected, we do not expect probably interactions. So we may go for a resolution 3 design, that is, we will be able to estimate the main effects, but they are confounded with second order interactions. The thing will be that we don't expect these second order interactions, and we are only interested in making a first exploratory analysis in which we analyze many possible different factors, and then in a second run, once we have identified the important factors, we will do a full factorial design or a fractional with much higher resolution. So let's say that we have 7 screening factors, and so we are screening 7 factors, and we will use only 8 runs. So we may start with something called a cyclic design. So a cyclic design, these are also called saturated designs. So you start with a cycle with well, all the treatments from 1 to 7, and here I have marked 1 just to for easy visualization. So now we cycle them. So we cycle them means that now we shifted to the left. So we shifted to the left. So the second treatment 2 goes here, treatment 3 goes there, and then the 1 goes on the right. And then we apply another shift. Now it is not a shift by 1, but a shift by 2. So now we have a shift by 2, and these shifts by 1 or 2, they are not kind of magic, but they are designing what are the properties of A transpose A, as we saw in the previous video. Okay, so now we will do 8 treatments. In the first treatment, in the first combination, we will put high, so all the factors will be low except variables 1, 2, and 4. In the second one, all of them will be low except 2, 3, and 5 that will be high, and so on. So this is a way of designing these resolution 3 designs. And yeah, so here it is the same idea that now we will have 8 runs, and then only factors 1, 2, and 4 will be so factor 1 will be valid only in 1, 2, and 4. So this 1, 2, and 4, and then 2, 3, and 5, 2, 3, and 5. So I said it wrong at the beginning. So only these factors will be high only in these runs, and all the rest will be low, and we add an extra point that will be all of them to high. Okay, so these are called these saturated designs. We can bring it to the extreme. So these Plackett-Burman designs, they are meant to analyze many factors. So for instance, let's say that you want to screen 16 factors. 16 factors is there are 2 to the 16 combinations, that is almost 65,000, not almost, more than 65,000. But you want to analyze all these 65,000 combinations with only 20 combinations of them. And as we have seen, not all of them are valid, but here we have a possible execution. So again, these designs are not unique, so there are many possible combinations, but this is one. So with only 20 runs, and these are so for the first run, A will be high, B will be low, C will be high, D will be high, E to G will, E to H will be low, and so on. So with only 20, we will be able to identify what are the main effects of these factors that are really important for our results, and then we will do the full factorial. So this, as you may imagine, it can save really a lot of experiments and animals and money and time and everything. So this would be all for the screening designs. That is, as you have seen, it is a fractional, an extreme fractional design, where we will be able to have resolution 3, meaning that we will be able to identify the main effects. They are confounded with second order effects, but still we don't have to do 65,000 combinations. So this would be all.